Before there was light, there was silence. Not the silence of an empty room, or the silence that falls after a storm. This was something older, something absolute. A silence so complete it had no name, because there was nothing yet alive to name it. No stars, no planets, no wind moving through the dark spaces between things. Only the universe, coiled within itself like a breath not yet taken, dense, formless, and infinite in its waiting. Then came the breaking. In a single instant so violent it still echoes through every atom of every living thing, the universe was born. Light tore itself free from darkness. Matter erupted outward in all directions. The great machinery of creation had switched itself on, and from that moment forward, the universe would never stop expanding. It has been expanding ever since. For 14 billion years it has stretched outward, silent and relentless, carrying with it the remnants of that first tremendous fire. Galaxies are racing away from each other even now, as you breathe, as you read, as you sleep. The cosmos does not wait. It does not pause. It simply moves deeper, darker, further, into distances that dissolve the mind like salt in warm water. And we, small as we are, have always looked up. There is something inside the human creature that cannot make peace with the night sky, something unresolved. Some ancient hunger that stirred the first time a prehistoric hand pointed upward at the cold scatter of stars and asked, silently, before language had words for such things, what is out there? Are we alone? Where does all this end? We built fire. We built tools. We built cities that could be seen from the mountains. We built ships that crossed oceans we once believed were the edge of all things. We were, from the very beginning, a species that refused to stay where we were placed. And so, of course, we eventually built telescopes. The first one was crude, a tube of glass and ambition, pointed upward by a man in Italy who had the audacity to believe that the universe will reveal itself if only you looked carefully enough. Galileo Galilei turned his instrument toward the heavens in 1609, and the universe was never quite the same. Jupiter had moons. The moon had mountains. The stars were not painted on a dome. They were real. They were distant. They were, in some terrifying and beautiful way, places. From that moment forward, humanity's eye grew sharper with every passing generation. Lenses gave way to mirrors. Observatories rose on mountaintops above the clouds. Astronomers spent their lives in cold, dark rooms measuring the light that had traveled unimaginable distances to fall, at last, upon their instruments. Each generation looked further than the last. Each generation revised what they thought was the edge of everything. Then, in the 20th century, something changed. We left the ground. On October 4th, 1957, the Soviet Union launched Sputnik into orbit, a small metal sphere beeping its way through the sky above a stunned and frightened world. It was barely the size of a beach ball. It carried no instruments of discovery, but it changed the direction of all that came after. If we could put a metal sphere into orbit, then eventually, given enough time and enough will, we could put an eye into orbit, an eye above the atmosphere, above the clouds, above the trembling blanket of air that blurs and distorts the light of distant stars like a reflection seen in troubled water. The idea took shape slowly, the way all great ideas do. In 1946, an astronomer named Lyman Spitzer, Jr. wrote a quiet paper that almost no one read. In it, he suggested something that, at the time, seemed closer to science fiction than science. A large telescope, positioned in space, beyond the reach of the Earth's atmosphere, capable of seeing the universe with clarity that no ground-based instrument could ever achieve. He called it, with appropriate understatement, the Large Space Telescope. No one acted on it. Not yet. The world was busy with other things, wars and revolutions, and the urgent, terrifying business of surviving the 20th century. But the idea did not die. Ideas of genuine power never do. They wait in the margins of papers, in the footnotes of lectures, in the conversations of dreamers who cannot stop thinking about what is possible. And then, in 1990, the dream partially came true. The Hubble Space Telescope was launched aboard the Space Shuttle Discovery on April 24, 1990. It was the most ambitious scientific instrument ever placed in orbit. The world held its breath as it was unfurled above the atmosphere, gleaming in sunlight, pointed toward the dark. Then came the crushing silence. The images that came back were blurred, not slightly blurred, profoundly, embarrassingly, catastrophically blurred. The primary mirror, ground with extraordinary precision, had been ground with extraordinary precision to the wrong shape. A flaw just over 2 micrometers, a fraction smaller than a single human hair, had rendered the most expensive telescope in human history nearly useless. The headlines were savage. The ridicule was swift. Some members of Congress called it a national embarrassment. Political cartoonists sharpened their pencils with obvious delight. But the people who had built Hubble were not politicians. They were engineers and physicists, and people whose entire lives had been devoted to the pursuit of clarity. They refused to quit. In December 1993, astronauts aboard the Space Shuttle Endeavour flew to the Hubble Space Telescope on a repair mission that many believed was impossible. 5 spacewalks. 10 days of meticulous, dangerous work conducted at the edge of space, in the cold silence above the planet. Astronauts floated in the void, used their human hands to install corrective optics, essentially a pair of glasses for a telescope, with a precision that bordered on the miraculous. When Hubble's new images came back, the world fell silent. Not from disappointment this time, from awe. Pillars of gas rising like cathedral columns inside nebulae, galaxies colliding in slow, apocalyptic grace, stars being born in nurseries of light and dust millions of light years away. Hubble showed humanity things that no human had ever seen, not in dreams, not in paintings, not in any vision or prophecy or sacred text. Real things, real structures, real light, falling on a real instrument, carried across real distances that the mind simply cannot contain. Hubble changed us. It gave us photographs that are now embedded in the cultural memory of our species. The pillars of creation, the ultra-deep field, the image of a tiny patch of sky that revealed 10,000 galaxies behind it, each one a universe of hundreds of billions of stars, each one unreachable, each one real. Hubble made the universe personal in a way nothing else had. It gave us faces to attach to the darkness. But Hubble had limits. Its mirror was 2.4 meters across. Its instruments were aging. Most critically, it looked at the universe primarily in visible light, the narrow band of the electromagnetic spectrum that human eyes were built to perceive, and the most ancient light in the universe, the light that left the very first galaxies when the cosmos was still young and fire-bright, does not arrive in visible light. By the time it reaches us, stretched across 14 billion years of expansion, it has shifted, dimmed and reddened, into the infrared, into wavelengths that human eyes were never designed to see. To see the beginning, you needed something new. And so, in 1996, a small team of astronomers began to talk seriously about what would come after Hubble. They called it the Next Generation Space Telescope. It was an audacious conversation. The kind that starts with someone saying something slightly absurd in the middle of a meeting and everyone in the room going quiet because, despite themselves, they are already imagining it. What if we built a telescope 10 times more powerful than Hubble? What if we put it not in low Earth orbit like Hubble, but 1.5 million kilometers away, beyond the reach of any rescue mission, beyond the orbit of the moon, at a gravitational balance point called Lagrange Point 2, where it could hide in the Earth's shadow and look out at the universe in a cold so absolute it would make Antarctica feel warm? What if we built a mirror too large to fit inside any existing rocket? A mirror made of 18 separate hexagonal segments that would fold like the wing of some extraordinary golden insect for the journey, then unfurl in the void of space. What if this telescope could see the first light that ever lit the universe? The first stars, the first galaxies, the very edge of time? The room must have been very quiet for a moment. Then someone picked up a pen, and the work began. It would take 25 years. 25 years of engineering that tested the limits of what human hands and human minds could accomplish. 25 years of designing systems that had to work perfectly. Every hinge, every motor, every electrical connection, in an environment where no repair mission could ever reach. 25 years of setbacks, delays, cost overruns, redesigns, political battles, near cancellations, and the slow, grinding, relentless work of making the impossible merely very difficult. The telescope was renamed, not to the Next Generation Space Telescope, but to the James Webb Space Telescope, named for James E. Webb, the NASA administrator who had presided over the Apollo program in the 1960s, who had believed in the agency when it needed someone to believe in it. There was some controversy about the name. There always is when history's ledgers are examined with the standards of the present. Webb's tenure overlapped with documented discrimination against gay employees in federal service. Scientists argued, letters were written, petitions were circulated. The name was kept. The argument continues to this day, an argument that is itself part of the larger human story, that the instruments of progress are built by imperfect hands, in imperfect times, by people who are simultaneously capable of extraordinary vision and ordinary failure. The telescope was built at the Goddard Space Flight Center in Maryland. Its primary mirror, 6.5 meters across, composed of 18 beryllium hexagons coated in a thin layer of gold, was assembled by hand, one segment at a time. Gold, because gold reflects infrared light with extraordinary efficiency, because gold does not corrode, because gold has been, since the beginning of human civilization, the metal we associate with things that are meant to last. Each mirror segment was polished to tolerances measured in nanometers, 1 nanometer, 1/1000th of a meter. A single strand of human DNA is 2.5 nanometers wide. The engineers who polished these mirrors were working at the very edge of what the physical world permits. They were not merely building a telescope. They were confronting the absolute limits of human precision. Beneath the mirror, a sun shield the size of a tennis court was folded and packed. 5 layers of material called Captain, each layer thinner than human hair, coated in aluminum and silicon, designed to block the heat of the sun so completely that while one side of the shield would face temperatures of 85 degrees Celsius, the other side, the side where the telescope's instruments would live, would rest at negative 233 degrees Celsius, colder than the surface of Pluto, only 40 degrees above absolute zero. At that temperature, the universe's infrared whispers will be audible. At that temperature, the oldest light in creation could finally be heard. The launch was delayed. Again and again and again it was delayed. The years passed, and the telescope sat in clean rooms, wrapped in foil, suspended in silent waiting. Engineers who had dedicated decades of their careers to this machine grew older beside it. Some retired before they could see it fly. Some did not live long enough. The telescope became, for many of the people who built it, the central fact of their professional lives, a presence so vast and demanding it was difficult to separate from the meaning of the work itself. Then came the year 2021. The world was exhausted. A pandemic had emptied the streets of cities. Science had never been more urgently necessary, and never more politically embattled. Trust in institutions was fracturing. People were tired of waiting for something to feel hopeful about. On December 25th, 2021, at 7:20 in the morning local time in Kourou, French Guiana, an Ariane 5 rocket ignited beneath the James Webb Space Telescope and began to climb. It cleared the launch pad. It cleared the clouds. It cleared the atmosphere. The fairing fell away, and there, briefly visible from tracking cameras on the ground, was a telescope, folded, glinting in the sunlight above the blue curve of the Earth, beginning its long journey outward. Christmas morning, a gift to the species. The next 30 days were among the most anxious in the history of space exploration. The telescope had 344 single-point failure mechanisms, 344 individual components whose failure would be catastrophic and unrecoverable. Any one of them. Just one. And there was nothing anyone on the ground could do except watch the telemetry and wait and breathe and try to remember that these were the hands of the best engineers on Earth, and they had done everything humanly possible, and sometimes that is enough. The sun shield unfolded, slowly, exactly as designed. The 5 layers separated in sequence, catching the solar wind, spreading to their full 42 feet, blocking the sun with the finality of a hand placed between a flame and a moth. The mirror segments unfolded, first one side, then the other, 18 gold hexagons opening like a flower in a void where nothing flowers. Then, over the following weeks, the 18 mirror segments were precisely aligned using actuators capable of adjustments 6 times smaller than a single atom. 6 times smaller than a single atom. The engineers were not moving metal at this point. They were suggesting to the universe that matter might be willing to arrange itself somewhat differently, and finding, with a relief that must have bordered on tears, that it was. The telescope arrived at its destination, Lagrange Point 2, 1.5 million kilometers from Earth, and began to cool, and cool, and cool, until it reached a temperature that would have been impossible to achieve on the surface of any world in our solar system, until the instruments were ready, until the universe was ready to speak, and humanity was finally, after all the years and all the waiting, ready to listen. In July of 2022, the James Webb Space Telescope released its first images to the world. There's a particular kind of silence that falls in a room when something extraordinary happens. Not the silence of emptiness, but the silence of fullness. The silence of people who have suddenly run out of words, because words were built for smaller things. That was a silence in auditoriums and conference rooms, and living rooms and laboratories around the world, when Webb's first images appeared on screens. The deep field image showed thousands of galaxies. Not stars, galaxies. Each one containing hundreds of billions of stars. Some of them appeared distorted, bent into arcs by the gravitational lensing of massive objects between them and us. Their light folded by the curvature of space-time itself, exactly as Einstein had predicted more than a century ago, now visible not in equations, but in gold and amber and red curves against the black. Some of the galaxies in that image are among the oldest objects ever observed by human instruments. Their light left them when the universe was less than 1 billion years old. It has been traveling for over 13 billion years. It entered Webb's golden mirror on a morning in 2022 and was translated into an image that a human being could look at and, for a moment, understand. 13 billion years. In your hands. On a screen. But Webb did not stop at beauty. It was not built for beauty, though beauty was what it gave us first. It was built for answers. And the answers it has begun to provide are pending things that the scientific community believed, with considerable confidence, it already understood. The earliest galaxies the telescope has observed are far larger, far more massive, and far more structurally complex than any model of the early universe predicted they should be. According to the best theories cosmologists have developed over decades, refined by generations of brilliant minds, tested against the best data that previous telescopes could provide, the early universe should have been a place of primordial simplicity, gas clouds slowly condensing, small proto-galaxies beginning to take shape over hundreds of millions of years. What Webb found instead were enormous, fully formed galaxies existing just a few 100 million years after the Big Bang. Galaxies that had no business being there. Galaxies that had grown too large, too fast, in ways that current models simply cannot explain. The term used by astronomers in their papers, normally a community of people devoted to careful, measured language, was universe-breaking, not because the universe had broken, but because our understanding of it had, finally and necessarily, reached a boundary, and boundaries in science are not endings, they are beginnings dressed in unfamiliar clothes. This is what the greatest instruments of discovery have always done. They have not simply confirmed what we suspected. They have arrived at the edge of what we know and leaned over, and found that what we thought was the bottom was only another beginning. Galileo pointed his tube of glass at Jupiter and discovered that the Earth was not the center of all motion. Hubble pointed his telescope at the fuzzy smudges that some called nebulae and discovered they were galaxies, island universes, each as vast as the Milky Way, each separated from us by distances that reduced all human experience to something very close to nothing. Now Webb has pointed its golden eye at the very beginning of time and found that even our best understanding of creation was incomplete. It will always be incomplete. That is not a failure. That is the nature of the project. The project of understanding the universe is not something that will one day be finished. It is something that deepens with every instrument we build, with every image we capture, with every calculation we revise. There is no final answer at the end of all this looking. There is only the next question, growing larger and more beautiful as we approach it. Webb has found something else, too. Something quieter than the age of galaxies. Something more personal than the structure of the early universe. It is found in the atmospheres of planets orbiting distant stars, the chemical signatures of molecules that are, on Earth, associated with life. It has not found life. That must be said clearly and carefully. in the way that science demands. It has not found life, but has found the molecules that, on the only world we know to harbor life, precede and accompany it. It has found them in places where, not long ago, we would not have thought to look. The question that the first human hand posed toward the night sky, are we alone, has not yet been answered, but it has been moved. It has been moved from the realm of philosophy and religion and personal belief into the realm of science, into the realm of instruments and spectrographs and data and reproducible observations. It is no longer simply a question we ask in the dark. It is a question we are beginning to be able to investigate. That shift is not small. Think of all that had to happen for this moment to exist. Think of the 14 billion years of expansion. Think of the first stars that lived and died and seeded the void with carbon and oxygen and iron, the very atoms that make up the hand that is reading these words. Think of the 4.5 billion years it took this planet to cool and shift and stir until something small and self-replicating emerged from a warm pool and began the long, improbable journey toward consciousness. Think of the 10,000 years of human civilization, the fires and the famines, the wars and the languages, the mathematics discovered independently on opposite sides of the world, the philosophy and the music and the science and the art, all of it accumulating, all of it building toward this moment. A moment in which a species that evolved to survive on the surface of a single planet has built a machine cold enough to hear the universe's first whisper and place it 1.5 million kilometers from Earth and asked it to look back in time. There is no word in any language I know that is sufficient for this. The James Webb Space Telescope will operate, if all goes well, for at least 20 years. In that time, it will observe thousands of exoplanet atmospheres. It will peer further into the early universe than any instrument before it. It will capture images of structures and events that do not yet have names because we did not know they existed until Webb showed them to us. It will produce data that physicists and cosmologists will spend the rest of this century analyzing. And in doing so, it will inevitably produce new questions. Questions we cannot yet formulate because we do not yet know enough to know what to ask. That is the gift that great instruments of science give us. Not just answers. Questions. The universe is approximately 93 billion light years across, as far as we can currently measure. It may be far larger. It contains, by current estimates, approximately 2 trillion galaxies. Each galaxy contains, on average, hundreds of billions of stars. Around many of those stars orbit planets. On some of those planets, conditions may exist that are, in some measure, similar to conditions here. In all of that immensity, in all of those 2 trillion galaxies, those hundreds of billions of stars per galaxy, those incomprehensible distances, we have confirmed the existence of life in exactly one place, here, on this small blue world, wrapped in its thin shell of air, orbiting an ordinary star on the outer arm of an unremarkable galaxy. Something happened that, as far as we know, is either commonplace throughout the universe or nearly unique within it. We do not know which. We have not known for as long as we have been capable of asking the question. And so we keep building instruments and pointing them outward and waiting. The James Webb Space Telescope is not merely a scientific instrument. It is a statement, a declaration, made in gold and beryllium and cold mathematics, that this species, for all its violence, for all its short-sightedness, for all the ways in which it continues to fail the standards it sets for itself, is also capable of this, of imagining something impossible, of working toward it for a quarter of a century, of placing it at the edge of the solar system and asking it to look back at the beginning of everything. It is a declaration that wonder has not left us, that the hunger for the horizon, the same hunger that drove the first human eyes upward toward the first ancient stars, is still alive, still burning, still capable of lighting the dark. Somewhere, at this very moment, Webb is looking. Its golden mirror is gathering photons that have been traveling since before the sun existed. Its instruments are translating ancient light into data. Its transmitters are sending that data across 1.5 million kilometers of space to the people on Earth who are waiting to understand it. The universe is speaking. We have, at last, built something worthy of listening. And the silence before the answer, that vast, patient, humming silence, is the most important silence there is, because it means the question is still alive, and as long as the question lives, so do we, Asterisk, some things are too large to know in a single lifetime. But every generation that looks up and refuses to look away moves us closer to what the darkness holds. Asterisk.